In this section, we're going to talk about multiplying and dividing by a monomial. So, in order to do this, you want to understand the distributive property, and you want to be able to multiply and divide monomials. Upon completing this presentation, you will be able to multiply a polynomial with one or more variables by a monomial, and divide a polynomial with one or more variables by a monomial. So to start off with, our procedure for multiplying by a monomial, we want to start by using the distributive property to multiply each term inside the parentheses by the monomial on the outside. For each term, you want to use the procedure for multiplying monomials. Remember that we want to multiply the coefficients, and for each variable in the term, add the exponents. Similarly, when we talk about dividing by a monomial, the first thing that we want to do is expand. So write each term in the numerator over the denominator. From there, we want to simplify each term by using the rules for dividing monomials. Divide the coefficients, or simplify the fraction, and subtract the exponents for each variable in the term. Note, though we haven't talked about it yet, if the exponents subtract to 0, then the variables and the exponents cancel out. Remember that anything divided by itself is 1 or cancels. Note, we will not divide by anything other than a monomial in this course. Before we move into examples, I want to show you that this is something that we've already done before. Note that what it says here is we want to use the distributive property. This is something that we've already done, but we've only done it with numbers in terms of what we distribute into the parentheses. And so our procedure is going to be very similar. We just have to worry about the variables now as well. So for instance, if I look at 2 times x minus 5, well, note that what we're doing is we want to multiply 2 times x, and we want to multiply 2 times minus 5. 2 is a monomial that we are distributing into the set of parentheses. And so note that, again, all we're going to do is bring our variables into it and distribute them along with a number. Now, for the examples that we're going to look at, I'm going to go ahead and do this in 2 steps. If you are comfortable enough with the math, it is possible that you may be able to jump to the answer without writing out all of the steps, and that's fine. But just so that I can show you exactly what I'm thinking, I will go ahead and write it out. So for example A, we have 2x times x plus 4. And so my first step is I want to go ahead and distribute the 2x to each term inside the parentheses. If we do this, we get 2x times x and 2x times 4. We want to simplify each term, so we want to multiply the numbers together and add the exponents. So for the first term, we get 2, and then note that each one of these x's has an exponent of 1, or x times x is x squared. For the second term, we want to multiply the numbers. We get 2 times 4 is 8, and we keep the x. We cannot simplify any further because x squared and x are not like terms, and so we are done at this step. For our next example, B, we have 3x squared times 4x cubed minus 5x plus 2. So same thing again, I'm going to go ahead and distribute. I get 3x squared times 4x cubed minus 3x squared times 5x plus 3x squared times 2. For each term, we want to go ahead and multiply the monomials. So I'm going to multiply my numbers. 3 times 4 is 12. And x squared times x cubed, we add the exponents, we get x to the 5th. Minus. For our second term, again, multiply the numbers, we get minus 15. Add the exponents, we get x cubed. And for the last term, we multiply the numbers, 3 times 2, and we just have x squared. And so we are done with that problem. So hopefully this is fairly simple for you, so let's go ahead and step it up and look at ones that have several variables involved. If we look at example C, we have 3x squared y times 4x cubed y squared minus 6x squared y plus 2. So same thing, I'm going to start by distributing. If we distribute, we get 3x squared y times 4x cubed y squared times the middle term, we get minus 3x squared y times 6x squared y, and times the last term, we get 3x squared y times 2. Now if we go ahead and multiply and combine our like terms, or combine our like bases, we get 3 times 4 is 12. X squared times x cubed is x to the 5th. And y times y squared is y cubed. For the second term, we get minus 3 times 6 is 18. X squared times x squared, add your exponents, we get x to the 4th, and y times y is y squared. And for the last term, we get 3 times 2 is 6, and keep the variables. So we get x squared y. We cannot combine anything, and so we are done. Okay, so now let's look at division. Division is going to be very similar to multiplication. We're going to essentially use the distributive property again. Note here, I want to divide every term in the numerator by the denominator. So if we do this, I'm just going to start by writing each term over the denominator. We have 16x to the 5th over 2x cubed minus 9x to the 4th over 2x cubed plus 8x cubed over 2x cubed. We can then go ahead and simplify each term. So we're just going to work fraction by fraction and just go one step at a time. So the first one that we want to look at is 16x to the 5th over 2x cubed. So remember that we're going to start by working with the numbers. I want to divide 16 by 2, giving me 8. And then remember that since we are dividing, we want to subtract the exponents. If you have 5 x's over 3 x's, you can get rid of 3 of them, leaving you with 2. So we get 8x squared. That's the first one. So now let's move to the second one. The second one, we have 9 over 2. I can't do anything with that, so I'm just going to leave it as 9 over 2. For the x's, we have 4 x's on top, 3 on the bottom, so I can cancel 3 of them, leaving me with just 1 x. And then for the last term, we have 8 over 2. 8 divided by 2 is 4. And here, our x's cancel out completely. So we have no x's in the last term. And so our final answer is 8x squared minus 9 over 2x plus 4. And you're done with the problem. Okay, so now let's go ahead and look at the last example. And we're going to do the same thing. So we're going to start by writing this as individual fractions. So I want to have each numerator, or each term in the numerator, over the denominator. So I get 15x to the 5th y to the 4th over 3x squared y minus 3x cubed y squared over 3x squared y plus 9x squared y over 3x squared y. Now we want to simplify each fraction. So 15 divided by 3 is 5. And for each variable, we're going to simplify it. So if we have 5 x's on top and 2 on bottom, we can cancel out 2, leaving me with x cubed. For the y's, y to the 4th divided by y. If I have 4 y's and I cancel out 1, I am left with y cubed. And that's our first fraction. Let's move to the second one. So the second one, my 3's cancel, so we don't have to worry about that. X cubed divided by x squared should leave us with just x. And y squared divided by y is just y. We're done with the second term, so let's move on to the last term. 9 divided by 3 is 3. X squared divided by x squared, those are going to cancel. And y divided by y, those will cancel. And so my last term will just be a 3. And so we are done with this problem. And that takes care of dividing. Again, if you can do this in your head, that's fine as well, if you can jump down to the answer. This one I'm not going to say you need to do more than one step, but if you need to do more than one step for yourself, then I do recommend it.
So multiplying and dividing by a monomial, when will we see this again? When using FOIL or extended FOIL, we will use the same basic concepts that we did here, just doing it several times in a particular problem. In the module we will talk about in the next module we will be talking about factoring out a GCF, which will involve dividing all terms by a common monomial factor. Once you are done with the presentation, go ahead and try the following problems on your own. Bring your solutions and any questions that you have to class. Please take a minute to go ahead and pause the presentation so that you can go ahead and work on these before moving on to the next slide. Go ahead and answer the following questions. How confident are you with the material presented in this section? What from this section needs to be explained further, and how much more practice do you need to be comfortable with the topic?